Combining radical expressions is similar to combining like terms. If you have 3x plus 4x, those are like terms. You have the same variable, just add the coefficients in front of the x's, and that would be 7x. If you have 3 times the square root of 2 plus 4 times the square root of 2, those are like terms because you have the same thing under the radical sign. You can combine those. Just like you added the 3x and 4x and got 7x, you're adding 3 times the square root of 2 plus 4 times the square root of 2 and getting 7 times the square root of 2. You don't change what's under the radical sign when you're adding or subtracting radical terms. If the radicands are different, so if what's under the square root sign is different, you cannot combine the expressions, just like you can't if the variables are different. So if you have 6x plus 8y, the variables are different, you cannot combine those. Those are not like terms. That cannot be simplified. Likewise, if you have 6 times the square root of 3 plus 4 times the square root of 5, notice what's under the radical sign is different, so those are not like terms. You cannot combine those. That cannot be simplified. If the indexes are different, you cannot combine the expression, just like with different exponents. So if you have 2x squared plus 7x to the fourth, you can't combine those. Those are not like terms. You have different exponents on the variable. So that cannot be simplified. If you had 9 times the cube root of 5 plus 8 times the fifth root of 5, notice the roots are different. The indexes are different. If the indexes are different, or if the radicands are different, what's under the radical sign, it cannot be simplified. So if you have different items under the radical sign or different indexes, different roots, those are situations where you cannot simplify those. You need to simplify if possible. 5 times the square root of 6 plus the square root of 6. So if you have 5 square root of 6 plus the square root of 6, it's just like 5x plus x is 6x. 5 times the square root of 6 plus the square root of 6, that would be 6 times the square root of 6. Just add the 5 in front of the square root of 6 and the 1 in front of the square root of 6. Do not change what's under the radical sign. If you have 6 times the cube root of 3 minus 2 times the cube root of 3, it'd be just like 6x minus 2x is 4x. This would be 4 times the cube root of 3. Again, do not change the root nor what's under the radical sign. 4 times the square root of 3 plus 4 times the cube root of 3. Notice the roots are different. One's a square root, one's a cube root. You cannot combine those. If the roots are different, you cannot combine those. That cannot be simplified. 3 times the square root of x minus 5 times the square root of x. It'd be just like 3x minus 5x is negative 2x. This would be negative 2 times the square root of x. Again, do not change what's under the radical sign. Do not change the root. 14 times the square root of x plus 3 times the square root of y. Notice you have different items under the radical sign. One's an x, one's a y. You cannot combine those. If you have different things under the radical sign, that cannot be simplified. 7 times the cube root of x squared minus 2 times the cube root of x squared. You have the same root. The root is both cube root. And you have the same thing under the radical sign, both x squared. So those can be simplified, or that can be simplified. It's going to be 5 times the cube root of x squared. Just take 7 minus 2 is 5, and still times the cube root of x squared. Radical expressions may require simplifying before adding or subtracting, so you may have to break down the radicals before you go to add or subtract them. We're going to simplify the expression the square root of 12 plus the square root of 75 minus the square root of 3. So first to look at that, you say, well, it can't be simplified. There's nothing you can do there because you have different things under the radical sign. But they might be able to break down into something that can be simplified. The square root of 12, that'll break into the square root of 4 and the square root of 3. The square root of 75 breaks into the square root of 25 and the square root of 3. And don't forget, you have minus the square root of 3 on the end. Square root of 4 is going to be 2. Square root of 25 is 5. And again, don't forget, you have that minus square root of 3 on the end. So now we're looking at the 2 times the square root of 3 plus 5 times the square root of 3 minus the square root of 3. Now let's think about this again. At the beginning, we thought, well, different things under the radical sign, you can't do anything with that. That cannot be simplified. But now, for each one of these, you have the same thing under the radical sign simply by breaking that down. So those are all like terms. You have the same roots and you have the same thing under the radical sign. So those are all like terms. You can combine those. Just take 2 plus 5, that is 7. And then 7 minus 1, that would be 6. And that is 6 times the square root of 3. Next, you have the cube root of 250 plus the cube root of 54 minus the cube root of 16. Again, you look at that and say, well, different things under the radical sign, it can't be simplified. But it might be able to break down into something that can be simplified. So the cube root of 250, that'll break into the cube root of 125 and the cube root of 2. 125 is a perfect cube, and 2 is what's left over. The cube root of 54, that'll break into the cube root of 27 and the cube root of 2. 27 is a perfect cube, and 2 is what's left over. And on the end, minus the cube root of 16, that'd be minus the cube root of 8 times the cube root of 2. 8 is a perfect cube, and 2 is left over. So the cube root of 125, that is 5. The cube root of 27, that is 3. And on the end, the cube root of 8, that is 2. So it'd be 5 times the cube root of 2 plus 3 times the cube root of 2 minus 2 times the cube root of 2. Now those are all like terms because you have the same root and the same thing under the radical sign. So those are all like terms. You can combine those. Take 5 plus 3, that is 8. And then 8 minus 2 is 6. So that would be 6 times the cube root of 2. We're going to simplify the expression 14 times the square root of 20 minus 3 times the square root of 125. See if you can break that down into something that can be simplified. Starting with the square root of 20, that'll break into the square root of 4 and the square root of 5. And then the square root of 125, that splits into the square root of 25 and the square root of 5. So 4 is a perfect square, 5 is left over, and in the other one, 25 is a perfect square, 5 is what's left over there. The square root of 4, that would be 2, so that's 14 times 2 times the square root of 5. And then the square root of 25 is 5, it's minus 3 times 5 times the square root of 5. Just multiply through that. 14 times 2 would be 28 times the square root of 5. And negative 3 times 5 is negative 15 times the square root of 5. So those are like terms. You have the same root, same thing under the radical sign. Those are like terms. You can combine those. 28 minus 15, that would be 13 times the square root of 5. Cube root of 54 plus the cube root of 16. See if you can break that down into something that can be simplified. The cube root of 54, that breaks into the cube root of 27 and the cube root of 2. The cube root of 16 will break into the cube root of 8 and the cube root of 2. So 27 is a perfect cube, 2 is what's left over there, and 8 is a perfect cube, 2 is what's left over there again. The cube root of 27 is 3, so it'd be 3 times the cube root of 2. And the cube root of 8 is 2, so that is 2 times the cube root of 2. Now those are like terms. You have the same root and the same thing under the radical sign. So you can combine those. 3 plus 2, that would be 5 times the cube root of 2. 4th root of 32 plus the 4th root of 48. See if you can break that down. 4th root of 32, that'll break into the 4th root of 16 and the 4th root of 2. 16 has a perfect 4th root. 2 is what's left over. For the 4th root of 48, that'll break into the 4th root of 16 again and the 4th root of 3. The 16 has a perfect 4th root, and the 3 is what's left over. So the 4th root of 16, that is 2. That'd be 2 times the 4th root of 2. 4th root of 16 here again is 2. That'd be 2 times the 4th root of 3. So those are not like terms. You have the same root, but you have different things under the radical sign. You have a 2 under the radical sign and a 3 under the radical sign. Those are not like terms, but that is as far as that can be simplified. The FOIL method, or distributive property, can be applied when you're multiplying binomials involving radical expressions. So we're going to multiply 4 plus 2 times the square root of 2 times 5 plus 4 times the square root of 2. Just multiplying two binomials, use the FOIL method or distributive property, your choice. So with the FOIL method or distributive property, we're going to take 4 times 5 and then 4 times the square root of 2. Then distribute the 2 square root of 2 through that second set of parentheses. 2 square root of 2 times 5, and then 2 square root of 2 times 4 square root of 2 on the end. So those would be the first, the outer, the inner, and the last terms of the FOIL method. Or again, you could think about distributing each one of those terms in that first set of parentheses to that second set of parentheses. Now, just multiply through that out front. 4 times 5, that's going to be 20. Then 4 times 4 square root of 2, that is 16 times the square root of 2. And then 2 square root of 2 times 5, that is 10 times the square root of 2. And then 2 square root of 2 times 4 square root of 2, that would be 8 times the square root of 4. Now, simplify this. So we're looking to combine like terms, looking to simplify any radicals that we can. So in the middle there, you have 16 square root of 2 plus 10 square root of 2. That would be 26 times the square root of 2. And on the end, the square root of 4, that is 2. So that'd be 8 times 2 on the end. Keep simplifying as far as you can go. On the end, that 8 times 2, that is 16. So we have 20 plus 26 square root of 2 plus 16. Look for any like terms that you can combine. You got 20 and 16. Those are definitely like terms. Combine those. That is 36 plus 26 times the square root of 2. That is completely simplified. That's as far as you can go. So that's what you get when you multiply these two binomials involving radical signs. 36 plus 26 times the square root of 2. Next, 3 minus the square root of 7 times 5 plus the square root of 7. Just distribute that 3 through that second set of parentheses. and then distribute the negative square root of 7 to that second set of parentheses. Watch your signs. So if you take 3 times 5, or the first terms of the FOIL method, then 3 times the square root of 7, the outer terms of the FOIL method, then negative square root of 7 times 5, the inner terms of the FOIL method, and negative square root of 7 times the square root of 7, those would be the last terms of the FOIL method. So either distributive property or FOIL method, it's the same thing when you're multiplying two binomials. Multiply through that. 3 times 5 out front, that is 15. Then you have 3 times the square root of 7, then minus 5 times the square root of 7. Again, watch your signs. And on the end, negative square root of 7 times the square root of 7, that'd be the negative of the square root of 49. So again, simplify any radicals that can be simplified, combine any like terms. 3 square root of 7 minus 5 square root of 7 in the middle, that'd be negative 2 times the square root of 7. And on the end, the square root of 49, that is 7. So you have 15 minus 2 square root of 7 minus 7. Combine any like terms. 15 and negative 7, you can combine those. That would be 8. So you have 8 minus 2 times the square root of 7. That is as far as that goes. Stop there. Do not make that 6 times the square root of 7. That is it right there. Those are not like terms. You cannot combine those. That is completely simplified. Going to square the square root of 3 plus the square root of 5. Whenever you square a binomial, you are multiplying it by itself. In fact, whenever you square anything, you're multiplying it by itself. So we're going to take the square root of 3 plus the square root of 5, multiply that by itself, the square root of 3 plus the square root of 5 again. We're going to use the FOIL method or distributive property. So with the FOIL method or distributive property, take the square root of 3 times the square root of 3, and the square root of 3 times the square root of 5. Then the second term of that first binomial, square root of 5 times the square root of 3, and then the square root of 5 times the square root of 5 on the end. Just multiply through that, simplify that. Square root of 3 times the square root of 3 out front is going to be the square root of 9. Then square root of 3 times the square root of 5, that is the square root of 15. And square root of 5 times the square root of 3, that is the square root of 15 again. And on the end, the square root of 5 times the square root of 5, that would be the square root of 25. Keep simplifying that, combining any like terms, simplifying any radicals. Out front, the square root of 9, that's going to be 3. On the end, the square root of 25 is 5. And in the middle, the square root of 15 plus the square root of 15, those are like terms. That's 2 times the square root of 15. So we have 3 plus 2 square root of 15 plus 5. Still, look for any like terms you can combine. The 3 and the 5, those are definitely like terms. If you combine those, that is 8 plus 2 times the square root of 15. That's where you stop. Again, do not make that 10 times the square root of 15. Those are not like terms. You cannot combine those. That is as far as that goes. 3 minus 4 times the square root of 2 times 5 minus 6 times the square root of 2. Just multiplying those two binomials, FOIL method or distributive property. Take 3 times 5, and then 3 times negative 6 square root of 2. Those would be the first and the outer terms of the FOIL method. Then take negative 4 square root of 2 times 5, and negative 4 square root of 2 times negative 6 square root of 2. Those would be the inner and the last terms of the FOIL method. Multiply through that. Out front, 3 times 5 is 15. Then 3 times negative 6 square root of 2 would be negative 18 square root of 2. Then negative 4 square root of 2 times 5, that is negative 20 square root of 2. And on the end, negative 4 square root of 2 times negative 6 square root of 2, watch your signs. It's positive 24 times the square root of 4. Keep simplifying that. Look for any radicals that will be simplified, any like terms that can be combined. So you have 15 minus 38 square root of 2. So you have negative 18 square root of 2 minus 20 square root of 2. That makes that negative 38 square root of 2. Then on the end, 24 times the square root of 4. Well, the square root of 4 is 2. So it'd be 24 times 2 on the end. Keep looking to simplify. 24 times 2 on the end, that's going to be 48. Everything else stays the same. So it's 15 minus 38 square root of 2 plus 48 on the end. Look for any like terms. The 15 and 48, those are like terms. If you combine those, that is going to be 63. So you have 63 minus 38 times the square root of 2, and that is completely simplified.